Now, the third question, compute mean, median, mode, and standard deviation for all given small dataset. Explain when each measure is appropriate. Now, the question asks us to compute mean, median, mode, and standard deviation for a small dataset, and also explain when each measure is appropriate. In my slide, I have taken example for test 1. Marks of a batch of 30 students. The marks include values such as 4, 6, 8, 10, 12, 12, 15, 18, 22, and so on. Based on this dataset, I have calculated the following statistical measures. Mean. Mean comes out to be 13.5, which is the average score of the class, but as I mentioned on the slide, the mean is pulled down by weak students, since very low marks reduce the average significantly. This tells us the mean is sensitive to outliers. The median, which is the middle value of the sorted data, is 12. The median gives us the real picture of the average student, especially when the data is skewed. Unlike the mean, the median is not affected by extremely high or low marks. So in uneven or imbalanced data sets, the median gives us a more stable central value. Third, which is mode. Mode, which is more frequently occurring value, is 12. Mode helps us to understand the most common patterns in the dataset. For example, if 12 marks appear most frequently, it suggests that a large part of the class is scoring near that level. Standard deviation tells, which is approximately coming out to be 7.2. A high standard deviation indicates high spread in the marks. This means there is a large difference between the high performance and low performers. So the teachers immediately know that the batch performance is uneven. Some students are doing very well, while others are struggling. Finally, I have mentioned on the slide that the same logic applies to number of dowry complaints per district or any real-world datasets where values are very significantly. So in summary, mean is good for normally distributed datasets, median best when outliers exist, mode shows the most common value, standard deviations show how the spread of the data is. So moving on to the next question, which is 3b. The question is difference between errors and artifacts, plus we also have to give 2 imputation techniques. Okay, on the screen you can see the table from our presentation where I have shown examples from both crime and datasets and student datasets to make the concept easier to understand. First, errors. Errors are incorrect values that appear in the dataset due to typing mistake, wrong measurement, or human error. In my slide, the examples are time examples. Age type equal to 150 instead of 15. Student example, test remarks entered 88 instead of 38. These values are very simply wrong and need correction because they violate logical rules. Someone cannot be 150 years old and student marks may accidentally be mistyped. Artifacts are not incorrect values, but distortions created due to the data collection process. These occur due to environmental issues, equipment errors, or system failures. Example includes all crime scene photos are overexposed because the police flashlight was too close. Second is quiz scores suddenly appear as 100 because the server mistakenly shows the answers. Artifacts are tricky because the value looks acceptable but does not reflect reality. Now let us move on to 2 imputation techniques. First is mean says average based imputation. In the slide I have shown crime example replacing missing age with the mean age of married woman in that area. Student example filling missing test 2 marks using the average of test 1 and test 3 marks. This is useful when data follows a fairly normal pattern and extreme values are less likely. Second imputation technique, KNN is neighbor imputation. This is smarter method because it uses similar rows to predict missing values. For example, crime example for missing age, find 5 similar cases and copy their average value. Student example for missing test 2 marks, find 5 students with similar attendance and similar test 1 marks and use their test 2 values. KNN imputation preserves natural patterns in the data and is more accurate than simple averaging. So the key difference is errors are wrong data values, artifacts distort the data due to collection issues, and the 2 imputation, average based imputation and KNN imputation help us recover missing or unreliable data. Hope you found this video more informative. Hope to see you in the next one.